Welcome to Period 2, Chapter 3.2, where we continue the Arithmetic and Geometric Sequence series lesson. So this is the 3.2 where we look in the arithmetic series. So last lesson, in the previous video, we look at the arithmetic sequence. So as arithmetic sequence means a sequence that has a constant difference. For example, 2, 5, 8, 11, 14. This is an arithmetic sequence, right? Because you can see it goes up by 3 each time. So if you remember from last lesson, we know the nth term is un equals a plus n minus 1 times d. So that's a sequence. Series, on the other hand, is a sum of the terms in a sequence. So using the same sequence, the series version will be 2 plus 5 plus 8 plus 11 plus dot dot dot. Just add up all the terms together. It's arithmetic because they still have a difference of 3. So arithmetic series, the formula is Sn equals n over 2 times 2a plus bracket n minus 1 times d. Very similar to the series. So sequence formulas, don't get them mixed up. So this arithmetic series, you got to learn 5 formulae altogether in the whole chapter. So you learn the first 2, sequence and a series. All right. So we know, so Sn is the sum of the first n terms. So if you have S5, that will be sum of the first 5 terms. If you have Sn, means sum to the first, n terms. So n, we know is number of terms. A will be the first term. D will be the difference. Well, I'm going to skip this example for now. We'll come back to this and the next one where we'll look at the proof. We learn how to apply the formula first before looking at how to prove them. Okay, right. So example, find the sum of the first 30 terms of the following arithmetic sequences. So we indeed have 2, 5, 8, 11, 14. So question A, okay, so we want to find the first 30 terms, will be S30 we're looking into. So S30, now for those who have a really bad handwriting, which I used to be, your S, your 5, your 3, be careful, they look very similar. So S30 equals to, I just write a formula, n over 2, bracket 2a plus n minus 1 times d. We know the a, so 30 over 2 is 15. A is 2, so 2 times 2, a is first term, right? Plus 30 minus 1 is 29. The difference, every time we're adding 3, so times 3. Just put in the calculator. You should get 1365, unless I made a mistake in my notes. Okay, right, 1365. Question B. Okay, so this time S30. Now, n will still be 30. 30 over 2 times 2a. A is 100. 2 times 100 plus 100 minus 1 times the difference. The difference now going down by 2. So the difference negative 2. Okay, so which equals to 15 times. You can, to be honest, you don't have to write out like what I did. You can just put in a calculator. 299 times negative 2. Just put in a calculator. You should get 2130. And last but not least, part C. Okay, so this time P, 2P, 3P, so let's write down. So the first term, A, is P. The difference, from P to 2P, we're also adding P, so difference is also P. N is 30. So we can use the formula again, as 30 equals N over 2, bracket 2A plus N minus 1 times the difference, which is P. So S30 equals to 15 times 2P plus 29P. 2P plus 29P is 31P. 31P times 15 is 465P. All right, and that's it for the example. Okay, that's how we can use the formula very straightforwardly. So, next example, find the least number of terms required for the sum. Now you see the sum means series. Okay, so we're going to use a series formula, not a sequence formula. To 4 plus 9 plus 14 plus 19, all the way, that will exceed 2000. So there are 2 ways you can do it. You can let Sn, you can either let Sn equal 2000, or you can do Sn greater 2000. Up to you. If you don't like to use, the greater than sign thinking, you might mess up, don't like inequality, do the equal sign. Okay, so I'll do both for you. So let's use the greater than, because exceed, right? So we know Sn is n over 2 times 2a plus n minus 1 times d, greater than 2000. the first number of terms, so we work out n. So n over 2, a is 4, so 2 times 4 plus n minus 1. The difference is 5, 2000. So what I'll do is, let me simplify the bracket. So 8, 5n minus 5 greater than 2000. So what I'll do is actually I'll times 2 on both sides. Because if I times 2 on both sides, that will help me get rid of this over 2 to that side. It becomes 4000. And I'll expand n into it as well. So 8n plus 5n squared minus 5n greater than 4000. So what I've done is I've multiplied by 2 on both sides. Also, I've expanded the bracket. 8n minus 5n is 3n. So if I see a quadratic in there, so I'll bring everything to one side, plus 3n minus 4000 greater than 0. Okay, then I'll put in the calculator. And so 5, let's put in the calculator, solve the quadratic. So 5, 3 minus negative 4000, I get n equal to 27.98 or minus 28.59. We know n cannot be negative, so straight away we can get rid of that. So greater than means n less than negative 28.59 or n greater than 27.98. So clearly we want, so n has to be 28 because n has to be greater than 27.98. We can't have a negative term. N represents the number, the position of a term. You can't have a negative position of term because the first term is always the first term. You know, you can't have negative. Right. What about Sn equals 2000? So same thing, basically same thing in here. You just work with a quadratic in here. So you get 8, you get up to the point where 5n squared plus 3n minus 4000 equals 0. And you solve n equals 27.98 or minus 28.59. So you can write equals perfectly fine, but because it exceeds 2000, therefore you have to write next line, therefore n equals 28. And that gives you full marks in the exam as well. Okay, so both way works. Right. So your turn. Okay, have a go. These practice questions. When you're ready for the answer, you can press play. Here are the answers. Well, 1A, very simply, I've just written down the value of A, D, and N for you, so you can check your final answer first, and then check your value. If you got it wrong, you can check your answers A, D, and N, see if you put it in the correct position. A very silly mistake a lot of students usually make is they substitute the wrong number, you know, the wrong thing in the wrong place. For example, instead of 2 times A, they substitute 2 times D in there, you know, so yeah, so if you substitute numbers correctly, that shouldn't be a big issue. For question 2a, then once you work out that of n, so you let the n over 2 times 2a plus n minus 1 times d equals to 670. Sub in the value of a and d in there. Solve as a quadratic, you should get n equals 20 or n equals 25. Cancel all the negative values. So some of you might be asking, so what about if you have two positive values? So which one do you choose? Then they will usually say, maybe find the first value of n that gives you the number, or, you know, or when they tell you n has to be greater than a certain number, they'll give you some condition that can help you to choose which one, okay, in exam. Right, so exam practice, okay? I'll let you pause the video, have a go, see if you're able to write down that arithmetic sequence first, and then try to do it, okay? So have a go, okay, part A. When you're ready for the answer, you can press play. So part A, okay, scheme 1. They increase, it start with P, and then you add 2t each time. So the sequence goes with P, P plus 2t, P plus 40, P plus 60, etc. And then scheme 2 is P plus 1800, and then increase by t each time. So P plus 1800 plus t, then P plus 1800 plus 2t. Now for part A, then when you show the total earned, now you have to read this words very carefully, because in series and sequence, it's always a question asking, is it sequence or series they're asking? When they say total, means series. Okay, so that's a keyword. Total means when we work out series. So we know series, okay, for 10-year means S10. So S10 equals 10 over 2 times 2A. A is P plus N, which is 10 minus 1 times the difference of 2T. Okay, so S10 equals, to simplify it, 2P plus, that's 9. 9 times 2T is 18T. If you expand the bracket, so S10 equals to 10P plus 90T, which is what they need. Okay. If you're happy with this, okay, if you want to carry on with part B and part C, okay, pause video, have a go. When you're ready for the answer, you can press play. So here are final answers for part B and part C. Okay, if you got it right, well done. Let's move on to the proof after this exam practice. But otherwise, let's go for this. Part B. Okay, first of all, you're told the total earned for both salary schemes are the same. So you want to work out the S10, the sum of the first 10 terms for scheme 2 as well. For scheme 2, for the S10, it will be 10 over 2 times P plus 1,800 plus 10 minus 1 times the difference. So you will do 5 and then expand bracket 2P plus 3,600. That's 9T. And if you expand the bracket, it'll be 10P plus 18,000 plus 45T. And what we know is we're told these two are equal. So we can let 10P plus 90T equals 10P plus 1,800, 18,000 plus 45T. Initially, I had actually doubts. How do we solve two equations? Because we've got two unknowns. Got two unknowns? But actually, my worry is nothing. When I actually work it out, the S10 in part B, I realized the 10p cancel out. So bring a 45 to the left side, becomes 45t equals 18,000. So if you divide by 45, you get 800. And for part C, you want to do, make sure you submit carefully. You want to submit to scheme 2. So question C, you want to submit to scheme 2. The salary in year 10. Right. Now, one thing you have to be careful is this is a year 10. So they only want to know the year 10. What it means is you want to work out the U10. So A plus N minus 1 times D. They're not asking for series. They're looking for the sequence. So U10. So A is, what's the A? For P plus 8, 1, oh, they're told 29850. So this is U10. Okay. P plus, oops, wrong color. 1,800. That's the A plus N 10 minus 1 times the difference. Difference is T. So 29,850 equals P plus 1,800 plus 90, 9 times 400. So if you put in calculator, if you actually, writing on the sideways bad habit. So if we take away 29,800, so 29,850 plus 9 times 400 times minus 1,800. So you subtract everything, make P a subject, you get P equals 24,450 as the answer suggested. Okay, right. So that's slightly trickier where they give you U10. So that's what I'm saying. You have to understand whether the question is asking for series or sequences. Sequence means the nth term in a particular term, particular year. Series means total. Okay, so now let's go back to the proof. Right, now the proof is examinable. So before we go through the proof, I want to show you the number version, the numerical version first. So prove the sum of the first 5 terms. Okay, so what to try to do is try to prove the first 5 terms. So we're trying to prove 2 plus 5 plus 8 plus 11 plus 14 equals 40. Now you might be asking, that's silly, why can't I just put in a calculator? That's the whole point. That's not the point of it. The point of it is we're trying to use this to draw some inspiration to see if we can learn the structure of the proof, to understand the rationale behind the proof for the next one, which we're going to use for something quite similar, where the algebra one, you can't just simply put in a calculator, can you? So let's have a look. So I'm going to write S5. Okay, so I know S5 equals to 2 plus 5 plus 8 plus 11 plus 14. S5 means the sum of the first 5 terms. Okay, I want to prove that equals 14. So what I do with next thing is I'm going to do a clever thing, which is suggested by the proof. I didn't come up with this. Reverse it, reverse writing it. So I'm going to write S5, reverse. So 14 plus 11 plus 8 plus 5 plus 2. You might be wondering, why do we do that? Now, next step. Okay, now see what happens if we add them up together. If we add them up together, S5 plus S5, 2 lots of S5. Okay, 2 lots of S5 equal. Now, if you do 2 plus 14, that's 16. 5 plus 11, that's 16. 8 plus 8, that's 16. 11 plus 5, that's 16. 14 plus 2, that's 16. So something quite magical happens, which is when we reverse the order writing it, we realize each pair add up to the same thing. 2 plus 14, 16. 5 plus 7, they all add up to 16. And we have to add them all up together. Right? So on the left-hand side, we have 2 lots of S5. On the right-hand side, we have 16, well, 5 lots of 16. We have 5 lots of 16. Okay, so in here, we have 5 pairs of 16, right? 5 pairs because we've got 1, 2, 3, 4, 5 pairs. Okay, 5 pairs of 16. So, so if we try to do 5 plus 5 times 16, that's 80. If you divide by 2, that's 40. That's proven. Okay, now take note of this number here, 5 and 5. Okay, we're going to use something similar for the algebraic version. Okay, ready? So, prove that the sum of the first n term of the arithmetic sequence is n over 2 times 2a plus n minus 1 times d. We have to prove the series. So let's write down the series. Okay, so let's write a series. So we start by, now by the way, in exam, this 3 marks. This is a 3 mark. It has happened, it has appeared in a real exam before. So Sn equal, so a is the first term. Okay, a plus d is the second term. A plus 2d is the third term. A plus 3d is the fourth term, plus dot, 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 dot. We have where the last term, okay, the last term will be a plus n minus 1 times d. Okay, that's a series. You have to write out first a series. Next, reverse it. Okay, we're going to reverse it. Reverse. So Sn equal a plus n minus 1 times d. Put the last term first. Okay, plus, what's the second last one? It will be a plus n minus 1 times d. Right? N minus 1, sorry, n minus, not n minus 1, will be n minus 2 times d. Okay, plus, dot, 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 dot. We have plus, this will back to the a term, right? Because this will be a plus d, etc. You can imagine. So now, what do we do next? If we draw like last time, we add them up together. Sn plus Sn, 2 lots of Sn equal. Now, if you do the pairing again, so, okay. Now, if you try and add them up together, a plus n minus 1d will become 2a plus n minus 1d, right? Let's try this one again. Let's try this one as well. A plus a is, again, is 2a. So just to make it a bit easier for you to read, what I'll do is I'll just underline this term, okay? If you think about expanded bracket, that's 2d plus d, that's n minus 1d. So you realize all of them should equal the same thing, like our previous one should equal 16. Okay? And you will imagine that give you the same lots, and all the way to this one, it'll be 2a plus n minus 1 times d. So then we need to think about how many pairs of 2a plus n minus 1 do we have? How many lots of that do we have? Now, last time we've counted there are 5 pairs. Now, 5 is not a coincidence number. 5 because we've got 5 terms. If there are n terms in here, there'll be n pairs of 2a plus 2n minus 1d. So 2Sn equals n times 2a plus n minus 1d. I'll explain in here. Sum to n terms. Oops, sorry about my writing. A bit ugly. Sum to n terms. Therefore, n pairs of 2a plus n minus 1d. So therefore n times. Okay, so if we divide the 2 over, it'll be n over 2 times 2a plus n minus 1d as required. So where the 3 marks are allocated, first of all, the first mark will be allocated to you writing the Sn perfectly, you know, and then the second mark actually will be given to you showing, you reverse it and you showing, you add them up and you show you can get 2a plus n minus 1d. And the last mark will be given to you knowing there's n lots of it and then divide by 2. So 3 marks. Okay, and that's the end of the arithmetic series.